Good day. Another session, another part of paper 1, which is one of the section that it's a application and a lot of calculations and interpretation as well. But rest assured, is the easiest to approach as long as the approach is good and relevant. In this case, it's normally question number 5 in a normal question paper, work energy and power. We have a question here that we are going to deal with today. That's from the recent papers. And then question number 5, they say an arrestor beds are used to help moving trucks to come to a stop when their brakes fail. The driver of a 30,000 truck driving down a steep road drives onto an ascending arrestor bed inclined at 28 degrees to the horizontal as shown in the diagram below. Now the first question, that is 5.1, they say state work energy theorem in weights. Remember, when you are stating work energy theorem, don't forget, go to the formula sheet. You will find the formula work net equals to delta EK. Then you define guided by this formula. W net has got 3 meanings. You can just say is a total work done, or you say net work done. Net work done on an object. On an object is equal to the change, that is the delta, change in kinetic energy of the object. That is the first one. Otherwise, instead of the work done on an object, you can just say or the work done. Instead of say total work done or net work done, you can just say work done by a net force. So the latter of the definition is the same, is equals to the change in kinetic energy of the object. That's 5.1. 5.2 in the question here, they're saying to us is preceded by a statement. The truck with failed brakes passes a point A at the beginning of the arrestor bed at a speed of 33 meters per second. The average frictional force on the truck is 31,000 while the truck moves up the arrestor bed. Yeah, fine, that's the average friction there. Ignore the rotational effects of the wheels, of course. They will have an effect if not ignored. Now 5.2, they say give reason why the net work done on the truck while moving on the arrestor bed is negative. There are many ways here that you can do that. Meaning that now, one, you can develop this one from a free body diagram. Let's say you'll have a free body diagram, maybe the one with components will make it easier to say FG perpendicular and your FG parallel or W parallel, FG parallel, and the other one will be your friction, and then the truck was just rolling, therefore there will be no force acting upwards. This is the free body diagram. Now looking at this one, you can just say the F net, which is the sum of FK and FG parallel. F net in this case is negative, that is the first one, negative, or F net acts in opposite direction. F net is in opposite direction. Or you can say, there are many here, you can say both friction, or just say F or FK, and FG parallel or W parallel are acting in opposite direction. Or just say are in opposite direction. That will be also correct. So fine, that's the case, no problem. Or just say delta ek is negative. So if you can just say delta ek is negative also, it will be okay, fine, because the final velocity will be 0, the initial is not 0, so delta ek will be negative. Now 5.3, in this case, use energy principles to calculate the minimum length of the arrestor bed needed to bring the track to stop. The final velocity of the track will be 0 now. So if you look at this free body diagram, the other one can be this one of your normal. Remember, in this case you are not asked to draw a free body diagram, but remember you can't calculate in this case unless if we are a genius, then without drawing a free body diagram. So in this case you can look at which forces are doing work on the object. No work, no work. Then the only two are doing work on the object is either FK or and FG parallel. And then here also no normal force doesn't do any work, and then FK and FG also, they are doing work. Fine. Then we can use work energy theorem, the easiest one, since we have defined it that side, then we can use it. That's the easiest. Or someone can use also even work done by non-conservative force. Remember, they both will give you the same answer as long as your interpretation is correct and spot on. Therefore the two will give you the same answer. Now in this case, which force are doing work, then there will be the work done by friction plus work done by FG parallel equals to half mv f squared minus half mv I squared. Fine. Friction is given. According to the statement is 31,000 multiplied by delta x is the one that we are calculating. Then it will be cosine of 180 degrees, and then plus work done by the horizontal, the parallel component of the weight. It will be the mass now mg, which is 30,000 multiplied by 9.8. Sine, we are given the angle there is 28 degrees, and then delta x, the cosine of 180 degrees. So equals to, the right hand side will be half 30,000 multiplied by oh sorry, this you don't have to struggle. 0 minus half of 30,000. Initial velocity is 33 meters per second squared. That is one way of doing it. But remember, when you look at this part, you can have other expressions in this case. The work done by the weight. So the work done by the weight, remember, as we taught, it can be 4 formulas. Can be mgh cos theta, or it can be what we have used now, mg sin theta delta x cos theta, or it can be negative delta ep, or it can be mg delta x cos of 90 degrees plus theta when the object is going up the incline, or 90 degrees minus theta when the object is going down the incline. So up the incline, down the incline. So that's the option. These are the 4 ways. So in our case, we only use this one, but you can use any. They will give you the same answer. Just something that you need to know about in this case. So using any of this will give. If they remember, if there's no height, you can always use your trigonometry to say, I don't have a height. This is delta x, and this is 28 degrees. Therefore, I can always have the height. Height will be now the vertical component, which will be delta x sine 28. So you can just substitute the height by delta x sine 28 and cosine of, because the object is going up the incline, therefore weight is doing negative work, it will be cosine of 180 degrees. That's the case. In this case, just to explain a bit, you will have mg delta x, which is calculated cos, because this object is going up the incline, then we'll have 90 plus 28, so you will get that 118. So if it was going down, it will be 90 minus 28. So that's the case. That's when you are using the last one. Otherwise, if you use this formula, this substitution, your final answer delta x should be somewhere around 96.64 meters. That is the length of the arrestor bed, the distance on the arrestor bed that will, at least in this case, according to this one, needed to bring the truck to a stoppage. That was 5.3. So now 5.4 is the last question. Here they say to us, the diagram below shows the same truck entering a descending arrestor bed incline at an angle of 28 degrees to the horizontal. Initial speed of the truck and the average frictional force on the truck are 33 and 31,000 respectively, meaning that remains the same. Which arrestor bed, ascending or descending, will enable the truck to stop, will be able to stop the truck in a shorter distance? Explain the answer in terms of the forces acting on the truck. As we said in 5.2, if you remember the 5.2, now we said if the truck is going up this one, the delta F net will be negative. Now, meaning that now if F net is negative on the ascending, because here now which one will stop, we'll have to choose that one first. It will be ascending arrestor bed, obviously. Now the reason, you get 1 mark there. The reason will be now F net is negative, or maybe let's talk about this one. Then we'll say ascending F net is negative, whereas descending F net will be positive. So you can come up with all sorts of reasoning here. Ascending, both as we answered in 5.2, both the friction and the weight component of the weight are acting in opposite direction, whereas in the descending is only friction that is acting in opposite direction. So that is the case, or just explain only in terms of the weight, to say in ascending the weight is acting in opposite direction, in descending the weight is acting in the direction of the displacement. So that will be the reason enough. This is the 3 marks in this case. Yeah, I hope the issue of work done on an object becomes easier, especially also sharing with you the work done by the weight. I hope you take note of this one. Very simple. You always depend on which one are you exposed to. You can use it quite often, but all of them will give you the same answer if used properly on a particular question. Until we meet again next time, thanks for now.